morning everyone. Today we are discussing about the topic of magnetic materials and superconducting materials or superconductors. Today we discuss about the topic of magnetic introductions of magnetic materials. The introduction of magnetic moment and superconductivity are two fundamental concepts in the field of electromagnetism. Field of electromagnetism and condensed matter of physics. When combined, they relate the groundbreaking technology in areas ranging from medical imaging, MRI, and quantum computing, like as storage devices of computers, hard disk, and our ATM and credit and debit cards. The magnetic moment is a vector quantity that represents the strength and direction of a magnetic source. Next. The formula of magnetic moment, mu is equal to Ia, where the mu is the magnetic moment and the unit of ampere into meter power minus 2, and then I is the current is unit of ampere. A is the area vector in the unit of meter square. So this is why called as mu is equal to I into A. So the unit of ampere into meter power meter square. And the magnetic moment is a very tiny material. Its individual atom or particles. Magnetic material is a substance made up of many atoms with the magnetic moments. And the representations of diagram, the magnetic moment is shown in the figure. It's like as a circular path of I, and the magnetic moment of two different types of dipole. One is N and another one is North Pole and the South Pole moment. Next. So its current carrying loop, if the current flow counterclockwise, magnetic moment mu points upward. Use right finger. So we have know the different types of rules of right finger thumb rules, right hand rule and left hand rule. So this is called as a current carrying loop material. And bar magnet moments mu points the south to north inside the magnet. So the direction of the internal magnetic field. So this is the diagram material N and S. And the common points of that both system create a magnetic field and have a magnetic moment vector indicating the direction and the strength. The magnetic moment vector is indicated the strength and the directions, like as compass material. Next. The applications of magnetic material, like as the storage of hard drive and credit card and ATM card magnetic aviations. And the MRI magnetic resonance imaging is a medical applications, and electric motors and generators have different types of magnetic materials. And the navigations of magnetic compass we use to directions, like as ship directions. And atomic structure studies of electron spin and copper spins and photon pairing methodologies. And the magnetometers, the measure magnetic field. And particle physics, identification particles using magnetic moments, and then cyclotron of particles to be deforming the newer technologies. Next. Advantages and disadvantages of magnetic moments. In the advantages, it helps understanding magnetic properties of material, like as atomic and molecular structures. And medical imaging, MRI is the very good applications to indicate our human imaging parts or any destroyed materials. Used in designing magnetic storage devices, like as hard disk, CD, and different types of magnetic moments are magnetic storage devices are very good advantages of this material. And then atomic and molecular structure analysis to determine the electron pair and the photon sparing devices are advantages of this magnetic moment. And the disadvantages of difficult to measure precisely at atomic level. Very smaller level of atomic level is the very difficult material, and affected by external magnetic field and temperature, and requires complex instruments and accurate detections. It's a very complicated to detect accurate values of the magnetic materials or complex instruments. Not all materials have a strong magnetic moment. We have different types of magnetic materials: diamagnetism, paramagnetism, ferromagnetism. So we have not all the materials have a strong material. We have a very weaker materials also we have. And then superconductors. The superconductors is the special type of material that can conduct electricity with zero electrical resistance, with cooled below a certain critical temperature. This means electric current can flow through without any energy loss. Superconductors also exhibit the Meissner effect, which means they can expel magnetic field, making the ideal for application like magnetic limitations, and they are used in advanced technologies like MRI machines, magnetized and quantum computers. Next. In the formula of V is equal to I into R, like as we already introduction part, we says the resistance is 0, like a superconductor's resistance are 0. So input R is equal to 0, so V is equal to 0. So V is equal to 0, the electrical will be discharged. Next. The field of superconductors diagram is shown in this figure, and then applications of superconductors like as MRI machines. MRI machines have a very good applications to the superconductors and the magnetic moments, and the maglev trains, which are very fastest train travel materials, like as the 600 km per hour. The train will be travel as a 600 km per hour travel time. Particle accelerator to guide the particles, power transportation, no energy losses to transport the one place to another place, and quantum computers to make the storage device, heavy storage device with the very low weighted material. Next, advantages and disadvantages of superconductors. It's a zero resistance, like as no energy loss, strong magnetic field uses in MRI scans and maglev trains, and high efficiency greater power systems. And the disadvantages of very low temperature needed, like as cooling is costly, and the expensive materials. It's one of the not a budget friendly material. It's very high expensive materials and difficult to maintain. So it's very difficult. The materials need to special care. Thank you.